Hey everyone, welcome back to East Tech Now. What if I told you that China's nuclear science elite, who've been building atomic bombs and particle accelerators, are now disrupting the chip industry and have just broken the 5-year-long monopoly held by the US and Japan on a critical piece of technology? You wouldn't believe it, right? Well, recently, the China Nuclear Group's China Institute of Atomic Energy shocked the global semiconductor industry by unveiling China's first ever high-energy hydrogen ion implanter, POWER-750H, and it's hitting international benchmarks like a pro. But this isn't just any ordinary machine. It's the final piece of the puzzle in China's semiconductor manufacturing process, the atomic-level scalpel that powers everything from electric vehicles to high-speed trains and solar panels. It's also a game-changer for China's power semiconductors. In today's video, we're breaking down exactly what this machine does, why it's harder to make than a lithography machine, and how this breakthrough is shaking up the industry. What is an ion implanter? Before we dive into the technical details, let's take a step back and break down what an ion implanter actually does in semiconductor manufacturing. A lot of people think that the lithography machine is all there is to chip production. Well, they're wrong. Semiconductor manufacturing involves 4 core tools: the lithography machine, etching equipment, thin film deposition machines, and the ion implanter. The lithography machine is responsible for drawing the chip circuit designs onto the wafer, and the etching equipment does the digging. But the ion implanter? It's the machine that injects the soul into the silicon wafer. Pure silicon doesn't conduct electricity. It can't become a chip. To turn it into a semiconductor that can process information, we need to dope it by adding other atoms. In the past, the process was done with something called thermal diffusion, which is like pickling vegetables. Just dump the wafer into a furnace and let the impurities seep in. But it's messy, imprecise, and totally random. An ion implanter is a precision weapon that uses atomic-level ion guns to shoot impurity atoms into the silicon wafer. It ionizes the atoms, accelerates them to insane speeds, and fires them precisely into the wafer at a controlled depth and angle. The level of precision is mind-boggling accuracy. Within 0.5%, it's like throwing a needle from 10,000 meters up and having it land perfectly through the eye of the needle. Ion implanters come in 3 flavors: low energy, high current, for shallow doping in advanced chips; medium energy, to adjust the chip's threshold; high energy, for deep doping, especially in power semiconductors. Here's where the breakthrough comes in. China's new POWER-750H is not just any ion implanter, it's a high-energy hydrogen ion implanter, the rarest and most critical tool for power semiconductor manufacturing. Why this machine is a must-have. You might be wondering, what exactly is a power semiconductor? Well, if the CPU and GPU are the brain of a chip, power semiconductors are its muscles and veins. They control the flow of electricity, convert voltages, and make everything work. They allow electric vehicles to go 500 plus kilometers on a single charge. They enable phones to charge to 100% in just 10 minutes. They help high-speed trains and smart grids run smoothly. They make the mass production of third-generation semiconductors, like silicon carbide, possible. Currently, the global power semiconductor market is rapidly growing, expected to reach $610 billion, with China already making up $180 billion of that market. It's a critical sector. But to build advanced power semiconductors, you need a high-energy hydrogen ion implanter. Why? Because these chips need to withstand high voltages and temperatures, and the silicon must be made super thin to endure those stresses. To achieve this, you need to implant a deep field stop layer inside the silicon, basically an elect firewall. This firewall requires hydrogen ions to be shot deep into the wafer tens to hundreds of microns at voltages up to 1,000,000 electron volts, MeV. Ordinary ion implanters only go up to a few thousand electron volts, so they simply can't do the job. Up until now, the high-energy hydrogen ion implanter market was dominated by US and Japanese companies, who held a near-total monopoly. In fact, in 2024, the top 5 companies controlled 95.6% of the global market, with machines costing over $5 million each. Not only are they expensive, but the supply chain is often unreliable, and after-sales support is sketchy. Every time China wanted to make a high-end power chip, we had to pay exorbitant toll fees to foreign companies. And that's why China had to develop its own. The global market might be massive, but the keys to the kingdom were in other people's hands. How did China pull this off? Here's where it gets crazy. The team that cracked this tech isn't from a traditional semiconductor company, they're from China's Institute of Atomic Energy. Yes, you heard that right. A group of nuclear physicists and engineers from China's nuclear sector crossed over into chipmaking to pull off this breakthrough. Why them? Because the core technology behind a high-energy ion implanter is a sequential accelerator, a technology that nuclear physicists have been perfecting for decades. It was originally used for nuclear physics experiments and particle acceleration, so they already had the expertise to build something like this. The working principle of this technology is like a two-stage rocket. First, negative hydrogen ions are generated and accelerated to a high voltage. Then, the electrons are stripped off, turning the ions into positively charged hydrogen protons. These protons are then accelerated further, gaining double the energy. With this nuclear-grade tech, POWER-750H achieved a maximum energy of 750 keV, perfect for deep doping, beam intensity and uniformity on par with international standards, 85% domestic production of core components, giving China full control over the entire machine. With this, China became the third country in the world to fully master sequential high-energy hydrogen ion implanter technology. This isn't just copying what others have done, it's 100% homegrown. From basic principles to full machine integration, merging nuclear tech with semiconductor innovation. What does this mean for the industry? This breakthrough is more than just a new machine. It completely shifts the landscape of China's semiconductor industry. Cost reduction. With domestic production, the cost of power semiconductor manufacturing equipment is expected to drop by 30%, -40%. No more paying foreign companies outrageous fees. Self-sufficiency. The long-standing issue of low domestic production in high-end power semiconductor devices under 30% localization is finally being addressed. Key sectors like electric vehicles, rail transportation, and solar energy can now rely on domestic manufacturing. Speeding up domestic progress. The ion implanter market for mature processes, 28 nanometers and above, is already largely domestic, with companies like Zhongke, Xinyuan, and Kai Shitong making steady advances. By 2028, we expect the domestic ion implanter market to exceed 25%, opening the door for full replacement of foreign-made high-end equipment. But let's not get ahead of ourselves. The international giants have decades of process data and expertise. Our machines still need refinement and consistency in mass production before full replacement happens. However, let's be real, this is a huge step. From nothing to something, from 0 to 1. The future of China's semiconductor industry. This is more than just a milestone for a single piece of equipment. It represents a step forward in China's push for self-reliance in its semiconductor supply chain. The successful development of the high-energy hydrogen ion implanter shows that China is gradually transitioning from a technology follower to a more independent participant in global technological innovation. With this breakthrough, a major bottleneck in power semiconductor manufacturing has been cleared. While China's high-tech industries still face challenges, the long-term outlook is becoming more resilient, and this is just one step in a long process. What do you think will be the next semiconductor technology that becomes a key focus for domestic innovation? If you want more updates on China's latest tech moves and the unique way China views its own technology, please like and subscribe.